Hi, this is Dr. Sheena here. Today, our topic for the discussion is composites. So, composite is actually a combination of two or more materials that have a chemically distinct interface between them. So, normally the composite consists of resin, the filler particles, and the coupling agent. So, it is actually a combination of two or more materials with distinct chemical difference. So, what is the composition of composites? It contains a resin matrix, filler particles, and coupling agent. You can see this image. Normally, the resin matrix forms the base, and on that there are filler particles which is embedded to that, and these two actually adhered by the coupling agent. Hope you understood. There is a matrix, on top of that the filler particles are there, and this resin and filler particles are joined together with the help of a coupling agent. So the matrix is mainly formed by resin components like bis GMA, tech DMA, UDMA, etc. Filler particles are normally the silica particles, colloidal silica, or the quartz, glasses of barium, zirconium, etc. is being added as a filler particles. So filler particle is the portion that give the strength, which reduces the shrinkage of the composite, etc. Coupling agent is an agent that join together the filler particles to that of the resin components. So normally organosilanes are the normal coupling agent that is used in composites, and also zirconates and titanates are also used. Now, resin matrix is also called as the continuous phase. So very important, resin matrix is also called as the continuous phase. The filler particles are also called as the dispersion phase, because as I said, the continuous thing that is actually seen is the resin, and on that there are small filler particles which is actually the dispersion phase, and these two are actually adhered by the coupling agent. Now talking about filler particles, as I said earlier, it consists of silica, quartz, etc. Actually, the filler particles is a substance which increase the strength of the material. It helps in the abrasion resistance, hardness of the material, and they reduces the polymerization shrinkage. What is polymerization shrinkage? When we actually apply the composite in a cavity and when we cure with the help of a light, what happens is like there will be slight change in polymerization take place. There will decrease in the amount of composites, or there will be slight shrinkage in the composite, which produces micro gaps in between the composite and also the tooth structure. So such conditions are reduced when there is large amount of filler particles. Now quartz is very hard, and quartz are used, it's really difficult to finish and polish a material. Barium, zirconium, and yttrium are the popular fillers. They also produce radio opacity, which help us to make it visible in the radiographs. Now, what are the various types of actually fillers? The first is mega fillers. Mega fillers are also called as inserts. These are small glass particles of size 0.5 to 2 mm that is mainly added to the posterior composite where there is chance of occlusal contact or high wear. This is to actually increase the wear resistance. So these are called as inserts or mega fillers. It's a size of 0.5 to 2 mm. So, if the composite consists of unfilled, simply the fillers and uncured matrix, it is called as a homogeneous mixture. If it consists of a pure pre-cured composite fillers or any other unusual fillers with a uncured uh, matrix, it is called as heterogeneous mixture. There, in heterogeneous, it will be pre-cured, while in the case of homogeneous, it won't be pre-cured. So next is the types of filler particles. First is megafill. Megafill is having a very large particles. Macrofill is having a size of 10 to 100 micron meter. Midi-fill is 1 to 10 micrometer. Mini-fill is 0.1 to 1 micrometer. Microfill is 0.01 to 0.1 micrometer, and nano is in the range of 0.005 to 0.1 micrometer. They are the ultra small fillers. As I said, smaller the fillers, more will be the wear resistance, more will be the strength, more will be the capacity to decrease the polymerization shrinkage, etc. Now, talking about coupling agent, very important. As I said earlier, coupling agent is the thing that bond the filler particles to that of the resin matrix. So, normally used coupling agents are the organosealants. Now, you can see in this chart, the organosealants is the coupling agent which is commonly used. Organosealants contain two important parts, that is a methacrylate group and the silane group. You can see in this image. So the silane group, as I said earlier, the coupling agent joins the filler particles, resin matrix, and the filler particles, right? You know that it actually joins the resin matrix and the filler particles. So organocylins have two hands. Think like it have two hands. The organocylins one hand is actually silanol group, that is a silanol group, which form a covalent bond with the filler particles. Very important, they form a covalent bond with the filler particles. So the organosilane contains the silane group form a covalent bond with the filler particle. Now the coupling agent have another part, that is the methacrylate group is there, methacrylate group. This methacrylate group do a radical copolymerization method to get attached to the resin matrix. Hope you understood. This is very important. Organosilanes think that it have two hand. One hand is silane. This silane form a coupling agent. This silane form a covalent bond with the filler particles, SCF. Next is the methacrylate group. They form a radical polymerization reaction with the resin matrix. Now, the composition or the classification of composite based on the method of curing. We know that for the setting of the composite to take place, there should be curing lights. So, first is self-curing composite. That means that there will be two composite paste, and when we actually mix them, they consist of activators within that, it will cure by itself. Next is visible light curing. We'll be applying the light source from outside. UV light curing, diol curing, which consists of a small curing within the composite, and also because of the light activation from the outside. And after that, it is staged curing composite. Talking about the chemically activated resin, there are certain terms that you need to actually memorize here. Chemically activated, as I said, there is no supply of light from the outside. There are two paste systems, paste A and paste B. The paste, when they are mixed, there starts the polymerization reaction. So paste A consists of benzyl peroxide. So what I've made is like, for chemically activated, I have made a code of A, B, C. C is the chemically activated. So for chemically activated, it contains benzyl peroxide and amines. See, A, B, C. So it starts from back. So the chemically activated resin have B, that is benzyl peroxide initiator, and C and A, that is a amines, that is a tertiary amine, or N-dimethyl p-toluene. Hope you understood this. So paste A and paste B is there. So when they are actually mixed, free radicals are produced. These free radicals are responsible for the activation or the process of polymerization reaction. So simple. So there is no requirement of light or an external source to activate the reaction. Next is visible light activated composite. So it is a single paste system, because we'll be applying that paste and we'll be curing from outside, right? The activator in this is a diketone. So in visible light, the activator is a diketone, that is again an amine, and the initiator is camphoraquinone. Very important. Camphoraquinone is the activator and initiator in visible light. However, it is benzyl peroxide in chemical. Just memorize ABC, so it will be so clear that for chemically activated resin, it is benzyl peroxide. While in the case of visible light, it is actually camphoraquinone. So this is actually the most popular composite that is actually used today at the visible light composite cure. And the light is actually given at the wavelength of 400 to 500 nanometer, and that is actually the blue color, blue visible light spectrum, and the predominant light that causes the maximum polymerization is at 474 nanometer. So this is very important number. 474 nanometer is the time at which the maximum polymerization take place in that blue region of visible light spectrum. So as I said here, camphoraquinone is the initiator. What happens is like when we actually apply light out from outside, the paste consists of the camphoraquinones. So what happens is like because of the light activation, that when 474 falls here, the camphoraquinone get activated on photon or on the light exposure. So it releases, it absorbs the photons and it releases the free radicals, and there starts the initiation of the reaction, right? So camphoraquinone get activated at 474, that is a blue range, and diketone is actually the activator. For darker shades, curing time should be increased because it need more of the depth of penetration. Okay. Now, visible light curing unit, talking about that is the light which is used for activating the visible light composites. It is healthy hazard is virtually eliminated. Health hazards are virtually eliminated. No warm up time is required. Just start the light, it will start on curing. Require a minimum of 30 seconds for adequate curing. So when we do a visible light, 20 seconds is actually required. But instead of visible light, nowadays UV light is also used for curing. So for UV light, it takes about 60 seconds is required. The tip should be, if this is the composite restoration, the tip should be away from the cavity so that it is 2 mm away from the composite. It can cure a depth of 2 mm, and if larger areas are to be cured, it is carried out in increment. So whenever we apply the composite within the cavity, 2 mm of composite has to be incrementally placed, then cure, then place, then cure. That is called as incremental technique. So hope you understood. The first was actually the chemically activated. This portion is very important in composite. Chemically activated, then visible light activated is there, which consists of camphoraquinones and also the amines is there, or diketone. Diketone is actually the term. Diketone is activator. And the light, talking about visible light is there, it need a curing time of 20 seconds, and UV light is there which requires 60 seconds is there. So this difference is very important. So chemically activated composite, that is chemically cured composite, as you can see, what happens is like, as I said, there is two paste system, paste A and paste B. We will be actually mixing it. So the polymerization, when we actually place within the cavity, the composite, the polymerization starts from the center. That is very important, right? While in the case of a light cured, we'll be applying composite and we'll be applying light from outside. So the polymerization starts from the periphery towards the center. Here it is from the center towards the periphery. That is one difference. Chemically cured, the polymerization is center. The light cured, it starts from the periphery. So here the curing is in one phase, we know, because since it is the chemical reaction taking place, it is one phase. While in the case of light cured composite, since we are actually giving light, it has to be done in increments, right? As chemical cure, the system set in 45 seconds. This system set only after light activation. Here the working time is limited. Here the working time is increased because each time increments has to be kept and it has to be actually cured. And there is chance of more wastage. Here less wastage is there. Surface finish of this system is not that adequate. Here it have good adequate finish. So as I said earlier, visible lights are also used. Nowadays, UV lights are also used. One difference we already studied, UV light require about 20 seconds of curing. UV light require about 60 seconds of curing. Next is the nanometer, that is the wavelength of light that is used. Visible light use 400 to 480, as I've already told, that is a blue range. This is 360 to 400, that is in the 300 range, right? The intensity of the system remains the same always. Here, the intensity falls with time. One of the problem with UV light is like it causes retinal damage. That is one of the most important problem with UV lights. But in the case of visible light, it is okay. It actually falls at a safe zone of 464. Now, what is the depth of cure for UV light? Depth of cure means whenever we apply the material into the cavity, how much depth will be cured at a particular time. The depth of cure for this UV light is 1.5 mm. So 1.5 mm of depth of cure is seen, and depth of cure for UV lights is like 2 mm. So 2 mm of cavity of the composite will be cured in the visible light. So these are the differences that you need to keep in mind. What is the advantage of light cure over self cure? We use the light cure which get activated by the light. Self cure is that chemical composition. It have an extended working time because self cure, like as we mix and keep, it starts setting. But other case we can actually do the carving etc. Then only we can cure it. It have extended working time. Less porosity is there in the case of light cure, and better abrasion and wear resistance. Next is something called as dual cure composite. As I said earlier, this have two property. It set inside also, it set when we apply the light cure also. So recommended especially in when we do a ceramic inlays that may have a thick appearance, so that light will the problem with the problem with light cure is that when we apply light from outside, if this is the cavity, here the amount of light reaching will be less. So in dual cure composite, where the restoration is very thick, better to have a dual cure. So there will be a curing by self itself and also activated by the light. Now a term. What is macroceramics? Macroceramics is a macroceramic. This is a reinforcing phase or a filler of first generation composite resin. So it is actually coming into the first generation composite, which consists of silicate based fillers like quartz, fused quartz, etc., and a particle size of 5 to 75. Just memorize that it is a older filler particles is used, like the silica based filler particle. It is a ceramic actually, macro ceramic, where the filler particles are reinforced, especially silicate filler particles are actually seen. Now, what is micro ceramics? This is the second generation composite, okay, which contain colloidal silicate based particles were here like quartz and all. Here pyrogenic silica of particle size not less than 0.04. That is the difference. Here it is like 5 to 75 micrometers. That's very large. That is why it's called as macro. Here the size is very small, 0.04 micrometer. Now we need to know some of the generations of composite. It's the generation of composite, not the dentine bonding agent. Composite. First, as we have already explained that are macro ceramics. Second generation we have already explained, which contain colloid and also micro ceramics. Right? The size is more in this. The size is actually less in this. Third generation is a combination of hybrid composite in which there is combination of both these two, macro as well as micro, in the ratio of macro will be more, 75 is to actually 25 ratio. Fourth generation is also a hybrid type, but instead of macro fillers, they contain heated, irregularly shaped and highly reinforced composite macro particles. So instead of the simply macro ceramics, we use heat cured. We'll be heat curing the fillers and we'll be actually reinforcing. That is the fourth generation. This was done to have a superior restorative property. Next is fifth generation. This is again a hybrid system in which the resin phase is reinforced with macro, and the macro is heat cured with spherical sized material. That is a difference. In the first type, there was irregularly shaped, but heating is taking place. But here it is more spherical. So what happens is like it is having good surface texture, where resistance is less, good mechanical physical property when compared to the fourth generation, etc. SC. So hope you understood. First generation macro ceramic, second generation micro ceramic, third generation combination of macro and micro, fourth is like combination of macro and micro, but we'll be heating it and it is having an irregular shape. Fifth generation, similarly macro micro combination, but heating it with a spherical shape configuration. And sixth generation is there. This is a hybrid type in which resin phase is reinforced. The resin phase, to that we will be reinforcing the microceramics and agglomerates of sintered microceramics, like normal microceramics also there, and we'll be actually sintering certain microceramics which join together by chemical bonding. That is also formed. That is the sixth generation. This is the best. It has the best physical and mechanical property of all the composites. So that are the generations of composite. It's very important topic. You need to know what are the parts of a composite, what is the mechanism how which the polymerization take place in visible cure, light cure, UV cure, etc. What are the generations of composite. Hope you had a nice class. Thank you. See you in the next class. Bye.